Welcome to this video in the Concept Development and Problem Solving program for R&D. In this video we will talk about how to improve creativity and turn it into an engineering tool. No subject we have been working with is so controversial and surrounded with so many myths. 3 common and widespread myths are: creativity is something you are born with. Either you have it or you don't, and there is nothing you can do about it. The best killers of creativity are rules, models, and systematic, as they will limit your thinking. You have to be in the right mode and state of mind to be creative. I am sure you have heard these myths before, but we believe they are more of excuses than myths. Suppose creativity is like playing tennis, golf or the violin. It can be trained, and the more you train, the better you become. Suppose systematic work methods would improve your creativity. Suppose that problem understanding is more important than inspiration. Suppose these aren't myths but facts. The easy path is to believe in the old myths. You don't have to change anything or learn anything new, and this video will be a waste of your time. The hard path is to challenge the old myths. It will put a lot of demands on you to change things, learn new skills, and practice them. Remember, things that are worth knowing usually don't come easy. If you're still listening, I assume you have decided to travel the hard path. The first step in this path is to stop trying to jump directly from problem to solution in a trial and error manner. That is only for people who travel the easy path. And by the way, this method is inefficient and works only for simple problems. Instead, you should spend time reformulating the problem to get a better understanding. The initial formulation is often vague or even wrong. Translating your problem into the functional language is a good way to start reformulating the problem. The biggest barrier to creativity is our paradigms, the so-called box. A paradigm is a concept your subconscious mind treats as fact, because of its effectiveness in explaining a complex process, solution, or set of data. Paradigms help your brain process data, but your brain has a hard time comprehending data outside of your paradigms. Paradigms are a common reason why we get stuck inside the box. Other factors are stress, lack of time and resources, and it is always safe to be inside the box. One misconception is that the best way to break paradigms is to go wild and brainstorm outside the box. I'm sure you have participated in such brainstormings before. You get many but raw and simple ideas. It is an illusion of creativity. So the second step on the hard path is to stop running outside the box brainstormings. What we propose you do instead is to draw boundaries for every brainstorming. Define new boxes to brainstorm within. Boundaries could be the type of ideas that are accepted or the way in which the problem must be solved. Some of the boxes should preferably also challenge existing paradigms. These are some promising boxes you could use. From a simple analysis of the customers that use your product in unusual ways, up to all the powerful tools, methods and algorithms in Triz. To learn Triz is the third step in the hard path, as Triz have many powerful tools, methods and algorithms for concept development and problem solving. Triz is based on the analysis of more than 1 million patterns. These analyses revealed some interesting patterns. They discovered that there is a limited number of typical problems and a limited number of typical solutions to these problems. It is therefore fair to say that there is a high probability that somebody else, perhaps in another industry, has already solved a very similar problem to yours. With the help of a Triz toolbox, you can tap into this huge knowledge base and get help to solve your problem. And it all rests on a philosophy of seeking ideality. The goal is to maximize customer value. In engineering, collisions such as weight versus strength, power versus fuel consumption, productivity versus space are common and lead to a situation called system conflict. You know how to improve one property like strength, but if you do it, it will impair some other property negative like weight. System conflicts are usually resolved by finding the best trade-off between opposing properties. From Triz standpoint, to make an invention means to overcome a system conflict. The presence of a system conflict is the most important characteristic that differentiates a difficult problem from a simple one. Let's exemplify this with a classic example. At the end of the 18th century, the daredevils in Paris were racing the streets on their speed carriers. Around 1850, pedals were attached to the front wheel. However, people's love for speed remained, and the problem formulation was how to increase the speed of a bicycle. Aspirations to increase speed made the front wheel bigger and bigger. Engineers had pushed the concept to its limits. A good example of how bizarre a trade-off solution can be, and how it can become a paradigm that blocks the development of customer value. The system conflict is, we want a larger wheel to increase speed, but we can't have a larger wheel because the ride gets too dangerous. The root cause for all system conflicts is a physical conflict, and in this case the physical conflict is that the wheel shall have two opposing properties at the same time. It should be big and small. It took mankind almost 10 years to come up with a feasible solution, and the bike moved up to the next S-curve. The previous example with the wheel is a good example of one of the strongest trends of evolution discovered in Triz, mono to poly. We can exemplify it with the evolution of loudspeakers. First came mono, which means that the sound is recorded with one microphone and played back via one loudspeaker. Next came stereo, where sound is recorded by two microphones and then played back via two separate loudspeakers. Next step is poly system with several loudspeakers. For example, you have two different loudspeakers on top of each other. But eventually the poly system is replaced by the convoluted system. You have several different loudspeakers in one box. If you look around you, you will see many examples of this. like airbags in a car, blades in a razor, or your camera in the mobile. This video has focused on 4 essential steps in the hard path to increase your concept development and problem-solving skills. The first step is to stop going directly for the solution. Instead, spend more time reformulating the problem and transfer the problem into the functional language. The second step is to set strict boundaries around our brainstorming sessions to increase the quality of the ideas and challenge the paradigms. The third step is to learn Triz. Triz offers a large toolbox to improve concept development and problem solving. The fourth step is to never go for a trade-off before you have seriously tried to overcome the system conflict. Things worth knowing doesn't come easy, but listening to this video was the first small step in the right direction. And if you continue to travel the hard path, you will be richly rewarded. And hopefully have I challenged your paradigms of what makes concept development and problem solving effective. Thank you for listening, and I hope you enjoyed this video.